Good afternoon. I'm going to give you a talk about different satellite systems. Everybody knows GPS, but what other systems that I actually really know right now? So that's Galileo, GLONASS, Galileo, and BeiDou. So in order to start, we can start with GLONASS. I'm not sure anybody is able to read Cyrillic, but that's written Global Navigational Satellite System. So after that, I will discuss GLONASS, Galileo, and the third one will be BeiDou. During consideration, I will stick to the different aspects of the system. The history, constellation, the satellites that are used, services that systems provide, ground segment, and future plans. After that, a small comparison will be given. So that's basically, there is a good technique actually that GLONASS, that's easy to compare with GPS because that's only two global positioning systems, and Galileo and BeiDou will be compared with each other and with other systems. So let's start with GLONASS. That's, as I said, the second of two global positioning systems that is operated by Russian Aerospace Defense Forces. So that's like GPS. That's primarily a military system, and then that's a system for the civilians. So a bit of history. The first satellite of the GLONASS was launched in October 1982. So it's good to compare also with GPS. The first satellite of GPS system was sent in the 1974. So by 1995, already 24 satellites of the GLONASS system were launched, and it was minimum amount of satellites to provide full coverage of the planet. The same amount of satellites for the GPS was already in 1993, a little bit earlier. So unfortunately later, due to economical reasons and problems, and without support of the system, only 6 active satellites left. And after major decisions were made, and by September 2010, already the system was recovered to the 26 satellites. So that again was fully operational. And today, the GLONASS system has 27 satellites, 23 of which are operational, and 4 satellites are used for tests and experiments. And GPS has 32 satellites, 31 is operational, 1 is used for experiments. Comparing the systems, the precision of the GPS of the GLONASS is a little bit higher than GPS, 36 meters. But the interesting case here that right now almost all navigation chip producers already can combine the systems using GLONASS and GPS simultaneously, and that provides precision around 1.53 meters. And this amount of accuracy can actually be very useful for us, for end customers, because this amount of accuracy already comparable with, for example, the line of arrow. So navigation systems can actually provide not only the information when we should turn, but also what line we should take. That's very good. So GLONASS satellite constellation consists of 3 planes, satellite planes. The height is 19,100 kilometers. The inclination of every plane is 64.8 degrees. In order to explain what is actually inclination, I have a small model. Let's assume that that's ours, and it's not rotating. So the inclination, that's an angle between the equator plane and the plane of the satellite. So for example, if the satellite is rotating exactly in the equator plane, like this, that means it has 0 inclination. When it has bigger angle, that means it has inclination. So the parameters of the GPS satellite constellation and GLONASS pretty different. The main difference is inclination angle, and according to the results, the bigger inclination angle of the GLONASS provides better coordinates determination in regions which are close to the north and south polar regions, and that's very useful for people, companies, and users who live there, because GPS provides not so accurate results. What actually GLONASS satellites are used right now? Right now, 92% of current installation consists of GLONASS M satellite. That's the second generation of GLONASS satellites. The first launch was in December 2003, and it provides frequency division multiple access signals. There is 4 signals. Here are the bands. There is a following notation. L1, that's a subband. Open OS, that means open or secured channel. And F stands for the frequency division multiple access. Later, I will also speak about code division multiple access. So the frequencies which are used are described by these formulas, and as you can see, number value n takes values from -1 to 8. You may ask, that's not actually enough for the 24 satellites. So in order to overcome that, different satellites which are opposite in different parts of the Earth use the same frequency, so they don't interfere with each other. So the next generation of the GLONASS satellite, that's GLONASS K. There is currently only 2 satellites in the orbits. They mostly use only for tests now, and they provide, additionally to the frequency signals, they also provide the code division multiple access signals in 83 subband, and frequency carrier is 1200 or a little bit more than 202 megahertz. So ground segment of the GLONASS system, ground segment actually combines all the stations which are used for control or for the monitoring of the systems. So interesting point is here in Moscow there is the main control center and all others stations used for the different system of differential control and monitoring. The future plans of the development of the GLONASS development is the following: is by 2000, starting from 2017 to 2018, they plan to gradually replace the old satellites which are using frequency signals to the new generation satellites called GLONASS K2. And by 2019-2020 to finish this replacement and only provide code division multiple access signals. And expected accuracy by this time is planned to be 60 centimeters. And additional point of development is increasing the number of the stations used for the differential control. So the next system which I'm going to describe is Galileo system. That's a global positional system of the European Union and European Space Agency. Unlike to the GPS and GLONASS, that's the only system which is intended primarily for the users, for the general users, not a military system. Current status of the system is in development, and some history about the system. In the October 2011, it was the first in-orbit validation satellite. They were used only to make some experience about the possibilities of navigation systems. And the first full operational capability satellite was already sent in 2014. The during 2015, plus six satellites were launched, and today amount of the satellites is 5 operational satellites and 4 of the satellites which were used and which were sent in 2015 will take some time to start operational. So the planned constellation of the satellite Galileo system is 30 satellites in 3 planes, and the expected precision is 1 meter for public signals and 10 centimeters for encrypted. So, because of the intention to use this system only for the users, there is a different set of services which Galileo provides. So the first service is open service. That's a usual coordinate determination service. The next one is safety of life services. That's additional to the open services in order to provide additional warnings when the precision of the system cannot be guaranteed. So this service can be mainly used for the ship or airplanes. The next service is commercial service. It's an encrypted channel for with better precision. The next one is public regulated services. They will be used for the government agencies, for example, the ambulance or police, and it will be guaranteed that this service will be working in any type of disaster. At least it is implied. And the last one is search and rescue service. It's provided to locate the distress beacon, which can be used by people, and also additional part to that not only to locate the beacon, but also to send the confirmation to the user that the help already on its way. So the Galileo constellation is pretty much similar to the GLONASS. It has 3 planes, a little bit higher, 23,000, a bit more than 200 kilometers. The inclination of 56 degrees and period of 14 hours 4 minutes. So the satellites which are used right now for the Galileo, that's full operational capability satellites. That's the second generation of satellites. The first was sent in the August 2014, and it provides 4 different CDMA signals. The spectrum of them, it's on the slide. The ground segment of the Galileo system is presented on this map. That's very interesting. Here, right now, near to Munich, there is Oberpfaffenhofen. That's a small place where there is a control center which is responsible for the Galileo, and also in Italy. There is in Fucino there is also the same additional control center, which these centers can operational simultaneously, and basically they can back up each other. Others point that's uplink stations or Galileo sensor stations, which are used for differential control addition. The development plan of the Galileo is by 2017-2018 provide initial operational capability, and by 2019 full operational capability. So the point when the Galileo should work, at least is planned to work, is 2012 to 2020. So it should contain 30 satellites, 24 active and 24 operational, and 6 active spares. The next system that I'm going to describe is BeiDou. That's the navigational system, satellite system of China. It's named after the Big Dipper constellation, and basically it is provided actually in the logo of the systems. So the current status of the system is it's regional operational. So people in China belongs to China can determine coordinates, and the global part of the system is in development. So the small system again, this is small history again. In October 2000, that was the first satellite of BeiDou 1 phase. That was the initial phase of the system. By December 2011, that was already operational in China. By December 2012, it was already operational in the whole Asia-Pacific region. And today it has 19 operational satellites. And the planned constellation of the system is 35 satellites in different types of orbits. I will say about these orbits in a second, different types of orbits. And the planned precision of the system is 10 meters for the public and 10 centimeters for the encrypted signals. So as I said, the BeiDou satellites constellation has 3 types of the orbits. The first one is geostationary satellites. That's the orbit of the satellite which provides for the observer on the Earth the satellite which will be hanged on, always in the same position. In the system there is five satellites with this specific longitudes. The next type of the satellites is inclined geosynchronous orbits. That's the satellites which rotates with the same angle speed as the Earth, but the orbit of the satellites is inclined. So they, in the sky, they make this interesting track of the 8. But I will say about that a bit later. And the last orbit is medium Earth orbit. That's the same orbit, like the same type of orbit which used for the GLONASS, Galileo, or GPS. So the satellites which are used in BeiDou system right now, that's the second generation of BeiDou satellites. They also provide CDMA signals in 4 different bands. The spectrum is on the slide. And interesting point also about B1 and B12 bands, that these bands slightly interfere with the Galileo system. And as I search currently, I have not found any news about agreements between Galileo and China that they somehow like sorted that out, which channels they are using, which channels they will be using right now. So, BeiDou satellites ground tracks, as I said, there is four on the picture 4, but right now it's 5 geostationary satellites. They always will be at the same point. So that's inclined synchronous satellites. They make this 8 tracks, and this is the line of the usual medium Earth orbit satellites. So the development plan of the BeiDou is by 2018-19 expanding BeiDou services to the customers of the countries close to the China of all Asia-Pacific region, and by 2012 expanding the current BeiDou system to the global navigation system. In order to summarize all the informations, all the parameters which I described, you can see at this table. So that's GLONASS, Galileo, and BeiDou, additionally with GPS parameters. As you can see, the most interesting thing from this sphere is actually GLONASS, because it has slightly different height, a bit bigger, greater inclination, and it provides right now frequency and FDMA and SDMA signals. So, in order to conclude the talk, I would say that during this presentation that was given an overview of satellite systems comparing with each other and with GPS. Currently, for the moment, only GLONASS together with GPS are currently global systems. BeiDou is operational, but it's only regional. And Galileo with BeiDou by 2020 will be deployed to the global state. all systems are using or plan to use CDMA signals. Galileo is the only system which primarily intended for the commercial and civilian usage, while others are primarily used for the military purposes. And BeiDou builds its satellite constellation using three different types of orbits: medium Earth orbit, inclined geosynchronous orbit, and geostationary orbits. Thank you very much for your attention. That's it.